Next up, we're going to be graphing f of x equals secant of x. This is our third example. Now, I will say, we did example 1 for sine of x. You can do the same thing with cosine of x. It's going to look almost exactly the same, just use the same steps. For example 2, we did tangent of x. You can use exactly the same steps, and you're going to see cotangent looks very similar. So I want you to do those on your own so you can get good practice. For step 3, we're doing secant of x. You'll see that cosecant looks very similar, and you're going to use the same steps. So let's recall from memory. Step 1 was to draw the chart using the same x values. Now, just as a refresher, those x values range from negative pi to pi. The reason for that is we want negative values and we want positive values, and it's very easy to move in increments of pi over 4 counterclockwise. So you're going to go from negative pi to negative 3 pi over 4, move in increments of pi over 4 counterclockwise all the way back to pi, which is the same as negative pi. That's 9 values. So for every chart we're using the same x values. It's going to be the same for secant. So let's go ahead and look at the chart. Our x values are going to be those 9 values. Next up, we need to figure out the y values. So for example, how do we figure out secant of negative pi? Well, going to the unit circle, if you recall, secant is 1 over x. So 1 over negative 1 is negative 1. Therefore, secant of negative pi is negative 1. Now remember, for the third column, you want those decimal approximations. So we kind of do 3 steps in one for the chart. Step 1 is to draw this chart. Step 2 is to determine the y values in unit circle. Step 3 is to convert those y values into decimals so that we can graph them. Okay, but for now we're just going to focus on the y using unit circle. So next up is secant of negative 3 pi over 4. If we go to negative 3 pi over 4, which again is pi over 4 to the right of negative pi, we're going to end up at 5 pi over 4. What's the x value? Negative square root of 2 over 2. Remember, secant is 1 over that, so the reciprocal of this is just going to be negative square root of 2, which again, as a decimal, square root of 2 is 1.4. That's something you need to know, basically. Square root of 3 is around 1.7. Those are some popular ones. So negative square root of 2 is negative 1.4. And again, we need the third column so that we can safely graph these y values, given these x values. Next, we have secant of negative pi over 2. Negative pi over 2 is right here, same as 3 pi over 2, which is 1 over x. 1 over 0 is undefined. And therefore, when we go to look at our chart, secant of negative pi over 2 is undefined. Now, I talked about this in the tangent video. You're going to have an asymptote there whenever you have a number over 0. So when we go to graph this, we're going to put an asymptote at negative pi over 2. Next, we have secant of negative pi over 4. Now, in this case, we're right here, and so x is going to be positive. 1 over square root of 2 over 2 is just square root of 2. Therefore, secant of negative pi over 4 is square root of 2, and the decimal of that is 1.4. Everything else in this chart is just going to be almost exactly the same as these up here. Secant of 0 would be 1 over x, and x is positive here, so it would be 1, and then so on and so forth. We're going to have one more asymptote at pi over 2, and that completes steps 1 through 3 for secant. And again, cosecant is going to be very similar to this. So now we have these sets of points. Here's our x values. Here's our y values. Let's go ahead and sketch the first one. The first one is negative pi comma negative 1. So we go to step 4 to plot each point on the graph. Start with the smallest one, negative pi comma negative 1. Next point is negative 3 pi over 4 comma negative 1.4. So we're going to go over to negative 3 pi over 4 and go down to negative 1.4, just above negative 1.5. Every other point on here is going to be exactly the same. So this leads us now to how do we connect these dots? Well, that's where the asymptotes come in. And again, we just said that there's going to be asymptotes at negative pi over 2 and pi over 2 because secant is undefined there. So for step 5, we're going to draw those vertical asymptotes for those undefined y values. Now you can start to see, well, I've got to connect these points. They're not going to cross with the vertical asymptotes. And you can also see it's not going to be like tangent, which is an S-curve. In fact, when I connect these and I hug the asymptotes, it's going to look more like a U-curve. Now down here, I can tell you that the pattern is going to be similar, except it's going to be pointing upside down. It has to curve around this asymptote, but at the same time, it's not going to just shoot diagonally. Okay, so it's going to be a U-curve on the left pointing down and a U-curve on the right pointing down. Therefore, when we get to step 6, we're going to connect the dots with a curve of best fit, and this is exactly what I described. And they are going to have arrows because, as I said before, tangent, secant, let's see if I can go back to that. Yeah, here it is right here. Tangent, secant, cosecant, and cotangent are all tend to infinity. So for step 7, draw arrows to the left and right of the graph to illustrate infinity. We're going to draw it just like this for secant. It's going to be 2 upside down u's and 1 right side up u in the middle of the graph. And let's go ahead and do that together just to kind of practice that. You're going to do upside down right there, right side up right here, and upside down right here. And again, cosecant is going to look a lot like this, except the u's are going to be in different positions. That's it for graphing secant of x. 7 simple steps. If you have any other questions about this, let me know.